Hey everyone, welcome to another test review. Today we're going to be going over the Chapter 9 test review for radicals. And as we're going through this is for Algebra 2, and I'm Mr. Hernandez. So let's get started. Question number 1, we want to find all the real square roots. This is a great way to start. All the real square roots of 0.0009. So square root we know is going to look like this. Oops. Alright, so square root is going to look like the square root of 0.0009. The only thing you want to remember of this is that when you're taking the square root, you're going to want a positive and negative. Whenever you take the square root of a value, or any of the even root, whether this is like 4th root, 6th root, whatever. Whatever the root is, you're going to have the positive and negative if it's even. So let's put this in our calculator and see what we get out. So add calculator, and we're gonna go, all right, the square root, so control square root and 0.0009. And let's see what we get with that. We're going to get 0.03. And notice how the calculator isn't giving us the positive and negative. So this is what you have to do, is you have to know that that's a positive and negative 0.03. So let's see, what are we getting? It's equal to positive or negative 0.03. Okay, for this question, here's how I pretty much have been teaching it during class, is that this cube root is going to go to the numerator and to the denominator. So the cube root, negative 125, divided by the cube root of 27. So remember, when we were putting this in the calculator in class, so the way I was doing it is, okay, so negative 125, and cube root to me means to the power of 1/3, divided by, and then the 27 can be to the power of 1/3 as well. So we're going to calculate both of those separately. So basically each one gets its own cube root. So back to our calculator. Let me see. So don't forget your parentheses on this room. The negative 125 to the power of 1/3. All right, so there that one is. And I notice how I get -5. We don't have like a positive or negative because it's an odd root. So we get -5 in the numerator. And then in our denominator, let's see, 27 to the 1/3, 27 to the power of 1/3. And I don't need the parentheses here because it's positive. So 27 to the 1/3, what do we get? We get 3. So we get -5 over 3. Whoops, let me get rid of that. -5 over 3. There you go. That's going to be our answer for number 2. Here we want to see what is a simpler form of this, all of this right here. And what you're going to want to do is split this up wherever there's multiplication. So we have 2 parts where there's multiplication. And so we're just going to have the fourth root of 81 times the fourth root of x to the 28th power times the fourth root of y to the 32nd power. Well, the fourth root of 81, let's see what that is. And actually, let me rewrite that first. So what that means is 81 to the 4th times, and what we could do here, or sorry, to the 1/4, And what we could do here is we could also do the same thing over for these, and say like x to the 28 over 4, because we're just going to divide them, and then times y to the 32nd power divided by 4. So let's calculate what each one of those are. So I have 81 to the power of 1 over 4, and that comes out to be 3, times 28 divided by 4. That's going to get me 7, but what you don't want to forget is whenever you have an even root and you finish with an odd exponent like we did here, so x to the 7th, you're going to want to put an absolute value around it. And then times y, and then 32 divided by 4 is going to get us 8. So that simplifies to be 8. And so this is the way your answer is going to look. You're not going to really need to change anything from here. This is pretty much your final answer. Number 4, here we go. We just want to multiply these two things. And what you want to see first is that they have that same index. So these have the same index, which means these can get multiplied. So all we have to do is multiply the values inside. We're going to have the fourth root. The fourth root of 11 times 6 gets me 66. And there's nothing else to do here. If we could, like if we could split this up into like maybe like the fourth root of 11 and like the fourth root of 6, but neither of those are perfect roots, so we don't want to split them up, and there's no other way you can really split up 66 to get a perfect root, so we're just going to leave it fourth root of 66. Moving here to question 5, we want to know what is the simplest form here. So pretty much we just need to multiply everything underneath the cube roots because they have the same index. So we're going to have one big cube root of 5 times 9, that gets us 45. And then x squared times x to the 5th, you add those exponents, so x to the 7th. Well, we want to split these up, see what simplifies from here. So like, let's see, the cube root of 45 times the cube root of x to the 7th. And you really want to know all these like perfect cubes and perfect squares and all these perfect roots that you can have. So for like 3's, for powers of 3, we can have, well, obviously there's 1, but then 2 cubed is 8, 3 cubed is 27, and 4 cubed, that's going to get us 81. And then I've already passed the 45 that we have here, and 45 is not divisible by any of these numbers. So again, this was 1 cubed, 2 cubed, 3 cubed, and 4 cubed. So since 45 is not divisible by any of these, this is going to be as simplified as it can. But remember, for this cube root of x to the 7th, we can write this as x to the 7/3. And then how many times does, you know, like if we wanted to simplify this, I could say 3 goes into 7 2 times. So really, how about this? How about we write it like, we kind of like just split it up. Could split this up. All right, so I could split this up, this cube root of x to the 7th, make it a little bit more obvious. We have the cube root of x to the 6th, and then the cube root of x to the 1st. Let me change the color there. So x to the 1st. There's a little 1 right there. So there's a little 1 right there. And we have cube root of x to the 6th. Well, that's something where we just need to divide, just like our last problem. So 6 divided by 3 is going to get me x squared. So let's see. From here, this is get me x squared. And now cube root of x, that doesn't simplify anymore, so that's going to stay in the cube root. And we don't want to forget what we had over here with cube root of 45. But this, the cube root of x to the 6th, does simplify down to x squared. So let's write that outside of the radical. So x squared times the cube root. Well, inside the cube root, the radicand, we have 45 times x. So if there's something to simplify after that, this is going to be the simplest form of this radical above. Now we want to see what is the simplest form of this one. So we have a large cube root on this one. So we could have like the cube root of, let's see, like 120x to the 17th divided by 5x. So one large cube root. And then we can simplify inside first. So we could have like the cube root. What is 120 divided by 5? All right, that's going to give me 24. 120 divided by 5 is 24. And then 17 minus the exponent of 1 right there. Let me put that in real quick. The exponent of 1 right there. So 17 minus 1 is going to get me x to the 16th power. Well, kind of like the first one, or the last one that we just did, 24 is not divisible. Actually, it is divisible. It is divisible by, let's see, let's start to split this up a little bit. We could have like the cube root of 8 times 3, because 24 is 8 times 3. That makes sense. And x to the 16th, let's see, what's the closest one I can get to that would be 15. So times x to the 15th times x. So then we just split it up like we did on the last problem because we know the cube root of 8. We know that the cube root of 8 is 2. And we know that the cube root of x to the 15th, well, 15 divided by 3 is 5. So that's my new exponent, x to the 5th power. Well, this is done. This is done. Well, everything else is going to stay inside the cube root. So the cube root of 3x. And that's going to be the simplest form of this this quotient right here. Now we want to see what is the simplest form of this radical expression. So what I notice here is that we have like radical expressions. So basically what I see is like 2u plus 6u, because those u's are the exact same thing. So this kind of like blah part right there. So those are pretty much the exact same thing. So all I need to do is just go 2 plus 6. That's going to give me 8. And whatever that u was, well, that u was the 4th root of 7x. And that's it for this problem. Over here, number 8, we're going to want to find the product of those two radical expressions. And here you just want to FOIL it out. So first, 4 times 3, we're going to have 12. And then 4 times square root of 10, well, that's just going to say, so plus 4 square root of 10. You don't multiply that inside because the 4 is not under a radical. And then we need to multiply here, 3 times the negative square root of 10, so minus 3 square root of 10. Again, you don't multiply inside because 3 is not under a square root. And then we have negative square root of 10 times square root of 10. That's going to be negative square root of 100. You do multiply underneath the radicals because they are both underneath square roots in this problem. Well, let's go ahead and start simplifying. So I have 12 plus, well, those, again, just like our last problem, or like radical expression, so I could go 4 minus 3. So 4 minus 3 is just 1. Let me put the 1 in there, but I'm not going to write it later. So plus 1 square root of 10. Well, square root of 100 over here, minus the square root of 100, that's minus, well, the square root of 100 is 10. So let's see what I have, because I still had 12 minus 10. I could combine both of those because those are both constants. So I have 2 plus 1 square root of 10. Well, 1 square root of 10 is just square root of 10. So we have 2 plus the square root of 10. Please don't write this 1 as you're doing it. We know that there's a 1 there, but I know a lot of you guys like me to write that. So 2 plus the square root of 10 is going to be our final product. Now here we want to write the exponential expression for x to the 4/3 in radical form. The thing that you really want to notice here is that the 4 and x are separated by multiplication. So it's not all getting raised to the power of 4/3. That 4 isn't being raised to the power of 4/3. All right, so it's just going to be the x, and let's take care of that first. So the denominator is going to be your index. So I had this x here, and the index is going to be cubed because, or 3, because that is the denominator in this exponent. And then the exponent on top of the x, the power it's getting raised to, is to the 4th power. And we don't want to forget this 4 out here. This is still getting multiplied by 4, but this is the expression written in radical form. Now we want to write what is the simplest form of this number, 9 to the negative 3.5. And what we want to do first with the negative 3.5 is convert that. All we need to do is convert that to a fraction. So we're going to have 9 to the negative, because it's still negative, and then 3.5 as a fraction. Let's see, that sounds like it's going to be 7 halves. All right, and the reason we convert it to a fraction is so that we can work with it in a second and put it in radical form. So now that we know that this is, let's see, yeah, this is 3.5. All right, yeah, perfect. Negative 3.5. Well, this negative part, all that means is the reciprocal. So we started here at negative 9, or 9 to the negative 7 halves. And then we need to write this out using, first let's handle this negative. So it's going to be the reciprocal. So 1 over 9 to the positive 7 halves. So we just needed to make that negative a positive, and in order to do that, we write it using the reciprocal. Now let's take a look at this. We could write this in radical form to see what this says. So this is going to be 1 over the square root of 9 to the 7th power. And what's neat about this is we can calculate the square root of 9 first. So let's go ahead and do that. I have 1 over, well, the square root of 9 is going to be 3. So I had 3 to the 7th power. And I don't really know what 3 to the 7th power is off the top of my head, but we could figure it out right here. 3 to the 7th power is going to get me 2,187. So what do we have here? Well, that's equal to 1 over, well, what was that number? 2,187. All right, and that's going to be the value that we're looking for, that exact number right there. Question 11, kind of a definition question, but what is the radicand? I've said this a few times as I've been going through this review, but the radicand, so is if we have like the square root or the cube root or the fourth root, no matter what's there, that's the radical, okay? The radicand is all the stuff inside of the radical. So that's going to be called the radicand, whether this is x or 2x to the fourth. You know, all of it, and everything housed underneath the radical is going to be the radicand. Next, we just need to simplify this expression. And what I said earlier was that we're going to need like radical expressions in order to combine these. And right now we don't, but let's see if we can rewrite this in a way that we will have like radical expressions. So first, what I noticed with the square root of 98 is I could rewrite that as the square root of 49 and the square root of 2. Both of those are getting multiplied together. 49 and 2 makes 98. Now, why did I use 49? I used 49 and 2 because the square root of 49, we know that that is 7. And let's do something similar over here. I can have minus 2, and there's a little multiplication right there. So minus 2 times the square root, well, 32, I can rewrite that as 16, the square root of 16 times the square root of 2, right there. Well, again, why did I use 16 and 2? Is because I know the square root of 16. The square root of 16 is 4. So let's write out everything I have. So I have square root of 49, that's 7, times the square root of 2, minus 2 times, well, the square root of 16, that's 4, times the square root of 2. Well, right here I can simplify 2 times 4. So I have 7 square root of 2 minus 8 square root of 2. And what I notice here at the end, I'm going to move the mouse right there. What I notice here at the end is that I have 7 square root of 2 minus 8 square root of 2. So this is pretty much like this last problem, or a few problems ago, where I had like 7u minus 8u. Well, I could subtract those because they have like radical expressions. Now, they didn't, or we didn't see that they had like radical expressions first, but after simplifying a bit, we do see it. So 7 square root of 2 minus 8 square root of 2, well, that is going to get us negative square root of 2. And that's going to be our final answer on this question. All right, here we just need to solve the equation that's given. So we're going to add 1 on both sides. And we're 5 plus 1, we're going to get 6 is equal to the square root of x minus 2. And then the inverse of square root, that's where we're going to square each side. So we're going to square each side. Well, 6 squared is 36, equal to, well, and then the square root squared, those cancel each other out. We're going to end up with x minus 2. Well, we can still keep solving for x. Whoops. We can continue solving for x here. All we have to do is add 2 to both sides and get 38 equal to x. and that's going to be our final answer for this. But whenever you're solving equations, you do want to make sure. So let's see if this does check out. So let's see. 5 equals square root 38 minus 2 minus 1. Let's see. Is this going to be true? Well, square root of 38 minus 2, that's going to give me the square root of 36. And then the square root of 36 is 6. And 6 minus 1 does equal to the 5 that we want it to be equal to. So 38 does check out. It is true. You just want to make sure and double check each of your answers. All right, here we have another one, but this one has 2 square roots. But the square root on the left side of the equation is already isolated. So let's go ahead and square both sides. Again, we're squaring both sides of the equation. So we can square both sides. Just throw in that parentheses to help us out. So we square both sides. Square root and square are inverses of each other, so we end up with x plus 15 on the left side of the equation. And then over here, we need to multiply this out. If you need to write it out twice, go ahead and do that. Well, what do we get from that? Well, 5 times 5 is 25. And then 5 times square root of x is 5 square root of x plus another 1 is going to be 10 square root of x. And then square root of x times square root of x is just x. All right, because we get the square root of x squared, and again, those are inverses. So let's isolate the square root part again. So let's see, let's subtract 25. All right, and subtract 25 here. So we're going to get x. And then minus 10 is equal to 10 square root of x plus x. And then let's subtract x on each side. Okay, this is nice. So then those are going to cancel out. So we get negative 10 is equal to 10 square root of x. Let's see. I could divide both sides by 10 now. We're going to end up with negative 1 is equal to the square root of x. And now I have another square root that is isolated. So since I have another square root that's isolated, let's go ahead and square each side, the entire side. And negative 1 squared is going to get me positive 1, and the square root and square cancel out again, so we're going to get x. So we're saying x is 1. Let's check our answer again. You always want to check our answer. We're going to get the square root of 1 plus 15 is equal to 5 plus the square root of 1. So is that true? Let's see. Well, this 1 plus 15, that gets me 16, so I get the square root of 16. And square root of 1 is 1, so I get 5 plus 1. Well, the square root of 16 is 4, and this 5 plus 1 is 6. That is not a true statement. So x does not equal 1. And we just need to come over here. You have to do this and label it as extraneous, if I can spell today. Label it as extraneous. Well, if we took our only solution that we had and we labeled it as extraneous, then we're going to say that we have no solution. All right, here to question 15. We need to solve this equation again. So let's see what happens. Let's see how we do on this one. Because this one has an exponent of 4/3, and we'll talk about how we need to get rid of that, what the inverse is going to be in a moment. First, let's isolate it. Let's subtract 9 on both sides. And we're going to get 3x plus 21 to the 4/3 equal to 90 minus 9 is 81. Well, how am I going to, what would the inverse be of 4/3? Well, I want to think, okay, what is going to make this a 1? What can I multiply by this fraction to make it a 1? And we can multiply this by the reciprocal, 3/4. We can do the same thing to the both sides and raise each side to the power of 3/4. Well, those are inverses, and I'm going to end up with 3x plus 21 equals, well, right here I have basically the 4th root of 81 cubed. So the reason why I wrote it out like this is because, and instead of just typing it into the calculator, is because whenever you have the fourth root, whenever you have an even index and you're taking it, like it didn't start like this, so I wrote it in and I'm taking the fourth root of each side, then you're going to definitely want the positive and negative of whatever this result is. So let's check what the result is. So 81 to the power of 3/4. That gets me 27. So I get plus and minus 27. And this 3x plus 21 is still over here. So I have two possible solutions. So let's split it up. We're going to have 3x plus 21 equals positive 27. Or we're going to have 3x plus 21 equal to negative 27. We just need to solve both of these. So we'll subtract 21 and get 3x equal to 6, and then divide by 3, and we're going to say x equals 2. Or let's solve this one, subtract 21 and get 3x equal to negative 48, and divide by 3. We're going to get x equal to negative 16. And again, just as before when we solved any of these equations, you need to check these solutions, see if they come out to be true. So let's check 2 first. 3x, so 3 times 2 plus 21 to the 4/3 plus 9 equals 90. Is that true?